How many people here use F-sharp at all? Yeah. You guys don't? You guys, if you haven't used F-sharp before, you should definitely be in a group with someone who has.
Yeah.
Just to make sure that you have because you have to know some syntax for this one. We're going to be talking about some of the newest stuff. So that kind of builds on some of the oldest stuff. We got a few guys here that definitely know F-sharp.
If anybody doesn't have a laptop or doesn't have 2000 Visual Studio 11 on it, feel free to hand them
I'm looking over your shoulder.
Yeah, if you want to look at
It's definitely better if you group up though. Or maybe you can move over there.
Get over.
So there's like two sides of it.
Well, I mean, do we have?
There's not a lot of seats up where you are.
I'll move if we have people who want to. I mean, at the moment, I mean, we can pull chairs around if you guys want to.
You want to do that?
Yeah.
It'd be better to have two teams because it's going to be. I plan on prizes, that's why I brought all this crap.
Oh, prizes.
Do you have a VM set up?
I always feel like prizes always motivate people a little bit.
Do you have like the CTP, the Visual 11?
Yeah, it's Visual Studio 11.
Do you have that?
Have you used F-sharp before? Oh, cool.
Cool.
I don't know, it's hard to know.
So how do you want to do this? You want to
Well, somebody just bring a chair over. I mean,
because
there's chairs.
Yeah. I just like to put a slide up to sort of emphasize the stuff that F-sharp has that C-sharp doesn't. Now, a lot of these words probably mean nothing to you if you haven't seen them before. They just might be gobbledygook. But they all are really important, and they all are very powerful features, actually. Everything on here is pretty powerful. So, in combination, it just makes F-sharp totally fun. That's pretty much how I feel about it. And I think a lot of other people feel the same way. But these features are really great for manipulating data, right? Like, that's sort of the idea with F-sharp. So you can write really small programs that are strongly typed, not like dynamic in Python, but similar in size. So you have the guarantees that they're not going to break when you change one thing. You know you have your cascading type changes that will autocorrect, or you have the compiler will fail because now you're trying to pass the string into a case int. But at the same time, you don't have there's so many type annotations and everything. The code is nice and small and indented, so it really compresses down nice and small. And there's tons of other things here, but I'm not going to get into them all. Most of these aren't important for today. F-sharp 3.0 has some new stuff. A lot of it was compromised stuff. The small stuff is now the core lives. So up till now, for every platform, the F-sharp team sort of released a separate version of their library. So you're doing Windows Phone, you use the Windows Phone version of the sharp lives, whatever. And it's not really the real solution that they've been putting off until this release is to do the portal profile, which runs everywhere. So that's what they're doing. They added auto properties to make certain things easier. F-sharp in general didn't have auto properties before because in general, part of the design of the language is to make a mutation painful. Now, and I know that sounds weird, make something painful, but it's really to sort of drive your behavior in the direction of making safe programs, ones that are less likely to break. But it just turns out that there's so many .NET APIs that want to get set properties that they got a lot of requests for it. So they ended up adding automatically back properties without having to specify it. The enhanced billable support actually goes along with some of the newer features and trying to work with link better. The IntelliSense is gigantically better than it was before. It's after going from the preview edition back, I'm like, oh man, I want this new, it's just F-sharp is a functional language. So actually there's academic papers being written about how to do IntelliSense properly while they're doing it. So it's they're figuring out how. It's not as straightforward as Java and C# where it's sort of obvious in the compiler. The compilers work differently too. So it's, but they've managed to think it through and actually really do a great job. It includes the parameter help as you're typing in. You can see things pop up in C#, which isn't the way it works now. It's just in the way in 2.8 with parentheses, and you can look at all the different type signatures, but as soon as you start typing, it all goes away. They also added a feature that was in the power tag for a long time, units of measure, which it lets you add units to any number. So then it's sort of you tag your type, and then at runtime, something that takes inches can only take a number that takes inches. But there's no computational overhead in this, which is the nice thing. And also it does automatic combinations of units and stuff. So that it's really nice for physics, or if you're NASA and you don't want to crash into Mars. So those kinds of things are really nice. But so F-sharp, part of the reason I love it is I work in very data-rich environments, and F-sharp is awesome for manipulating this data, but sort of the problem, even in C#, is that it's kind of painful to get the code, the data in that you want. There's like a bunch of setup involved, and especially if the external source changes. God help you if you have a crappy DBA that's always changing stuff on you, because it's like there's no way to know. So right now, the kind of solution in C# and everywhere else is they use lots of code gen. They've got a separate code generator for all of the things that you deal with, and then they generate code, like a real code, like C# code, and then the C# compiler turns that into something. Now, that's not very flexible, but it's the best that we could do with what was available at the time. They've been doing it for years, starting with like the win forms and everything else. The code gen has been a key part of the .NET framework. But we can definitely be better. And it's a lot of the reason that people are sort of leaving the .NET framework and going to these dynamic languages, because it's so hard to get out and get the data you want to play with it, get in the right form. It just really like, they add these features, but they're like little band-aids on a huge gaping wound, like like having a dynamic keyword. Now you have to write out infrastructure and the dynamic keyword for like stuff. It's just great. So, Don Syme, who's the creator of F# and a pretty awesome guy. If you haven't seen his videos on type providers, I recommend checking it out just for the feel. Like his vision is awesome. But he's saying that we have this problem, especially, he probably wouldn't say especially in the .NET world because he works at Microsoft. But I feel like this is true. Where our world is super information rich. We're making these apps that just like require crazy amounts of information, combining information, analyzing it, running algorithms. But like our languages don't support that very well. They require lots of pain to sort of fit your model into the language. And so F# 3.0, I think, is the answer to this with type providers. So these are the two big features in F# 3.0. The first is query expressions, which are like link but better. They can do stuff that you can't do with normal link. And type providers, which is essentially compiler extensibility that lets you generate types at compile time or generate code based on something in an assembly. That's what we're going to be talking about mostly today. I'm going to do a run through for everyone that hasn't heard about it yet on what F# 3 is and where it's going and why it's important and all that stuff. I think it's so cool. So the whole idea is that we have all these sources of data, right? Like this is just a small subset of what most of us deal with on a pretty regular basis. And then, but we want to just hook it up and then get our types out. We want real types, not dynamic types, not guess. We don't want them to change when someone like reloads a database, or we want to know. We want our compiler to tell us when things break. So we want the safety of what we consider statically typed programming languages, but with dynamic data out there. And that's sort of what we get with this. Of course, everything is a trade-off. If you don't compile again, and the thing changes out there in a way that breaks it, you're going to get exceptions, but that's going to happen anyway. And this is sort of your friend in that. It'll try to figure things out and make things happen for you. And you can write your own, which I think is the coolest thing. So this is just a little bit more on it. The real focus on this is data access and information services. And it layers on top of the successes of F# and then C# and VB before it, with the experience, the UI experience. Then you have your data analysis and transformations. And now finally you can actually pull that data in to get it to the visualization stage that much, like in a way that's not going to make you pull your hair out. Thankfully, I have been using F# for a while, so I still have my hair. Maybe a little bit too much, but I definitely came close to becoming bald when I was using C#. Anyway, so just to reiterate a little bit, the whole idea is that now you're in the compiler. The compiler that compiles the code, but also the compiler that generates your IntelliSense. You can do whatever you want. You can make stuff. You can say things to the user as they're dotting in. And so you have this space of types that doesn't even necessarily exist. They exist while they're being generated, but they're not necessarily in the output, right? You can do so much because they can just vaporize at compile time and it just turn into a string. Or you can actually generate this whole family of types that do complicated stuff. And with that, you get this huge extensionful compiler way before Roslyn and in a probably easier to use way, because it comes with this whole framework for building these types and sort of sucking in the data. And actually with Roslyn, they're talking about, from what I understand, mostly being read-only anyway, so it's going to be really hard to like really pump data into the compiler. A lot of it's going to be about analysis and trying to figure out better ways to improve algorithms. Although, who knows what they'll do? I mean, it's all preview stuff. And
what is that roster?
it's the new C# and VB compilers that are coming out. Like actually, they unified the C# and VB compiler. So now they're alternate syntaxes of the same language, which they always were really mostly. And now they're going to have a plugin for the compiler, which should be pretty cool. I bet there'll be some cool stuff coming out of that. But no one really knows how far it'll be, how easy it'll be used, like, and when it'll come out. Finally, I think this is the really important thing. As someone who works in the sort of big data universe, I see that most people are using dynamic languages. You know, even Octave for the ML class online right now is really popular. It's like a sort of supposed to be equivalent to AppDAP, but it's open source.
And does it have IDE?
Well, there's an IDE for Windows. Yeah. And but so like I think this is really sort of the best of both worlds. Is sort of what I'm saying. Like you get the sort of the short syntax, the easy transformations and everything, but you get the big problem I have with dynamic languages. I always had, is I wrote some PHP embarrassingly enough at some point in my life. I don't really want to talk about it in the dark days. And the and JavaScript and other things. I would have problems where I could crank up the code fine and go back to change it. It's really easy to break stuff, just because the compiler isn't helpful to you at all. Like you don't know. And also, if you have people working on the same thing, you just don't know when it's like collision, someone's going to like overwrite your stuff, like weird sort of corner cases. And I mean, with JavaScript, just typos in the functions, which is so infuriating. But here, like the compiler is getting the types for you. So there's always this idea I talk about at work with my boss about like we create our own little universes, sort of. He loves SQL. He's he's really into normalization. So like he wants to try to take the messy world out and make his logically sound world inside of SQL. And I see F# as being similar in that. Like I make my type set sort of logically coherent. So if one part changes in a way that's breaking, it'll cause cascaded breakage and the compiler will fail. This is one of those things in F# that you can do when you start leveraging like a lot of complicated things in it. You don't need to at first, obviously, but it really can get really cool in terms of what you can do with these types. So like, in equivalent, we do the same thing. We have these walls at the edges of our programs, and we like make sure that stuff that doesn't, like I would break it, doesn't come in, your guards and stuff. And then you write everything so it sort of folds in on top of these types. So it sort of forms a puzzle. Puzzle's not the right word, but like it is sort of like the square brick goes in the square hole, but there's lots and lots of different kinds of bricks, like you think about the types. But there's can be different types of squares. There can be blue ones and red ones, and there's some holes that take any square, and some holes that can take a blue one only. But it sort of works like that. And definitely F# is awesome for building programs that are really sound. But the problem has always been that it can always fail at runtime just because you didn't think of something having to do with a data set or something like that. And now the actual compiler will go out and it'll get the analysis, the details of the data set and provide you with types that are sound. So like now the wall is built by the compiler and it's much more sound and much less work. Don likes to emphasize the less work thing because he's trying to appeal to sort of the mass audience, but like this thing about the soundness of types, and of course it's not perfectly provable. There's definitely always corners, but this is really what functional programming is all about, and it's something that it's hard to convey until you get into it a lot. But it really is like the end of the road, the golden road. Once you get there, you see how your programs are much safer. Anyway, I'm sorry, I get into a little bit too much maybe, but it's there's so many people here that don't have a lot of experience. I just wanted to say that that's why functional programming is awesome. Like these types, they seem like this. Why would they be complicated types? But they really provide a safety net that nothing else can.
So is that the type, is the user-defined type, or is it the type that an F# that can do internally?
We build them out of the constructs that in F# like discriminated unions. records and such. And obviously, Haskell is sort of that whole idea taken to the extreme, where actually F# is sort of like Haskell Junior in terms of the type safety world, but it still has a lot of that. And that's sort of like where the units of measure come in. It's like now you have your integer, and integer isn't just integer anymore, it's an integer inches, which is hugely different. It's a hugely different idea. Anyway, that's a whole idea in F#, and it's something that I'm really serious about. But I think that isn't necessary to really embrace if you want to play with F# and even gain a lot from F#. It's really sort of like what happens when you've been using F# for years. You start seeing how your code doesn't break anymore. Really, like it doesn't. Like I don't get bugs, like weird, like null exceptions in the middle of nowhere. I used to get all kinds of crazy bugs in my C# that were just related to like the structure of the code, and I don't get those in F#. I get occasionally my logic was wrong. I was Monday morning before coffee. Tried to do something too complicated, like or convert some pseudocode into an algorithm or something. Messed up some case, but really, it doesn't break in the normal like null exception way that you're used to having happen all the time in C#. But getting back on track, because I don't want to go on too much about that. This is sort of what the new type providers look like. So you define your type provider here, and it actually provides you a type. So there's a type definition. This generates going away, Don said in the final release, but here you just have to specify this is a generated type by the compiler. So you can see a little hint at the end here of this is a static parameter to this thing. So these get pulled in at compile time and then passed to this. And then this provides you with your DB schema. Then you can get your thing out of that, and then you can start dotting into your database with that. And there's nothing else involved here except for a connection string. Like there's no schema file. There can be if you want to, and you want to have like that available so that you can code on the bus or something. But it's not necessary. And then here is just like a basic data set that comes with the F#3 samples. One of my favorite examples is Netflix because it's open and anyone can use it. Their OData service is available for anyone. So you can just say like, okay, I want my Netflix data service, and then I want to find all the avatars, things that say avatar. So you just write your, this is like equivalent of link, the new query syntax. So for T in Netflix titles, where avatar. Or you can even do, sort by the name and take the first 100. But you can do all this stuff transparently with just an OData service in the cloud. And this actually generates the types, iterates over them, and there's no anonymous types like in C#, so that the things that get returned by this can be passed anywhere. Yes?
I have a question. That query expression is new in 3.0?
It's new in 3.0, yeah.
Oh, it's not too, okay. Because I was getting confused between the sequence expressions. It's not the same.
Well, just for the people that already know F# somewhat, I don't want to confuse you guys on this new stuff, but F# has a bunch of lower level constructs that stuff in the language is built out of. And this is not how they do it in C#. In C# they just put stuff in the compiler, but in F# they make a low level thing and then build higher level stuff out of it and then give that to you as a user. But then really experienced people can make stuff too using those low level constructs, which I think is awesome.
Think of it as levels of compiler extensibility.
Yeah. But so like what they did here is they had something that they had for sequences, sequence expressions. So you can say like, for I, sort of like the yield keyword in C# where you can make a function, or I guess you can do it with lambdas. You can do it with a function method. So I'm just not using method now. Where you just like do a for loop and yield everything, right? And then you have this like enumerable thing. It just returns an enumerable, and you can put that anywhere. Well, you can just say like sec, and then the thing, and then you say for t and something else that's a thing, like yield that, and that'll just return enumerable. So F# has like these things called comprehensions, but those are actually built on top of this thing called a computation expression. And these are actually built with that, with some new stuff. And that stuff is super complicated, so I'm not going to get into it. I actually have a talk on that maybe I'll do again sometime. But it really is not easy. So in the data samples, if you want to take a look at some point, there is a bunch of examples of how this works. And I'm going to go through one of them in a minute, just real quick. But this is what's in the box in the preview edition. So there's quite a few different type providers that are provided for you. Of course, the Microsoft one's going to be great. There's going to be some probably, like the user ones will vary in quality. But Don is hoping that people will actually make ones and sell them. Because there's lots of cases. I mean, when I thought it would be awesome to have a key invoking, where they have all these key invoke generator utilities, right? Why not just have a type provider you point at a DLL, generates your types of that DLL, and then gives you them? I think that would be sweet. But anyway, so just a real quick, it's already 7, huh? Oh, I guess it's okay. So let me just drag this over. Just to look quick at something that I like a lot about this, is you can say, so this is like a database. These are, so for people that don't know, these are FSX files, they're script files. F-sharp can be run out of script files, which just pass into an interpreter, or it can be compiled into assembly. Either way, you still get your strong typing and cell sense and stuff. But in any case, I should make this big. All right, let's get rid of that. All right. Hey. All right. Can everyone see that? Yeah.
Yeah. Yep.
Okay, cool. So these R's are pretty much the same thing, having a reference in your solution. They're not pretty much, they are exactly the same thing. And then we open up our namespaces and modules, which are sort of like a static class. So we generate our DB schema here, just like in the example. We have our connection string. We just have it in there, and we take this back to DB schema type. And then we get our data context, and we can run a query on it. But we can actually group join. So here, like, what you would do with a database out of work looks like this. This is how I came across this, and I'm really impressed by it. It looks like this. Made by people. This is what happens in DBA. You don't DBAs. You have programmers. They don't make foreign keys. They don't even make primary keys. They just like put stuff in the database and like, oh look, it's a database. Oh my god. That's what legacy is all about, right? Working through those hard problems. They've done a pretty bang up job in general. It's just, some of these things are really old. So coming back, come on, maximize. Okay. So normally you would do like a group join. Where's my cursor? This is weird. DM presentations are always a little bit difficult. Can I get down? Yes. Okay, I'm just going to down. Anyway, we're just like, you have two things. One thing I do often is I've got, or one data set, which is particularly heinous that I deal with all the time, has a person with a primary name, a set of aliases, and a set of alternate spellings for that name. And why they are all different in different tables, nobody knows. But it's how it goes, right? So here I'm just getting the aliases, and I do my group join into something called g-aliases, and then I select the table, and then the g-aliases. That's great if you're doing one thing, but if you put two group joins there, how does it know how to deal with that? So, I mean, I'm not a database expert either, but one thing you can do here that you can't do in Link is you can actually put, this let keyword is a binding, a variable binding. And you can actually put like, okay, for each of my aliases, for each of my tables, get the aliases, this query here, has another table of DB aliases, and then it selects that out by doing a join, and I get my alternative spellings, and then I just select, and it gives me back all like lazily evaluated sequences, table 1 aliases and alternative spellings, which is really nice, because actually if it's all linked up properly with the foreign keys and everything, you can actually just dot into anything, and it'll do the odd joins automatically, which is really sweet. And I went into my own data set playing with Visual Studio 2011, and was like, oh, I can't wait to try this, and then I was like, wait a minute, none of the stuff they promised me works. And I looked at it and I was like, who made this database? And but then I emailed the team and I was like, how do I deal with this? And they were like, oh, well, you can just bind it. And it's really nice. This has like 1 million records in it too. Like the main header table that like links to everything else has 1 million records and it runs pretty damn fast. So it's not, so this is just like where I output it. That was my own little experiment. Now anyway, I'm going to go back to the code. Oh yeah, I'm in my VM. Okay. I wanted to share that with you because I was super impressed by the fact that I just handled it. If you want to grab a key to get the thing for the other person, like right there, if you have the preview installed, that has some code that you can be helpful. Okay, so this is a very simplified version of the world of typewriters, but I like this because it just, I don't know, it's kind of cartoony. Super compiler, and then we generate types. They can either be erased types or regular types. And raised types are types that aren't there anymore by the time the code is turned into an assembly. They're just temporary types that stick around for a little while, but you can actually do like pre-computation with these and then make everything evaporate, which is really nice. And then you have your normal types, which are just types, and they end up in the final assembly. But a lot of times, you want to like dot into a database, or one of my favorite examples that actually we're going to have you guys do is try to make something that you point at a directory in your file system and generate a type provider that gives you all of the files in that directory. So you just dot into that. You just take dot, you get the file. The parameter is the path, and then you pick the file. That's all, and have it return the actual path. So just to focus your mind on that while we're working through these. These examples will give you everything in the next few slides. Will give you all you need to do this project, mostly. If you have any questions too, I understand this is not simple stuff, but I just want you all thinking about it. So I just want to take a break for a minute and say that type providers, this whole DonScience vision really is to bring all the data from the outside in, but they can do some other cool stuff. Like one of the samples they give is a validating regular expression utility. So if you validate if your regular expression is correct or not correct or not, but it's a valid regular expression, and then fail if it isn't.
It's more than that. It also makes the in the example they give, if you're doing a regular expression which has groups, it gives you strongly typed access to the group data, so that you don't have that whole poorly thought out regex API of, okay, now I have to get the groups, now I have to remember the name of the group is a string, pass it in as an indexer. You just do dot and your group name pops up, and boom, there's your value.
So that's the awesome thing, is that the contents of a string inside your program can be kind of thought of as data coming from the outside, because normally your program at the compiler doesn't look at those strings, mostly, almost never. And now these typewriters can actually give you insight into those strings, validate them, and actually give things and take strings correct output. And it's pretty darn cool. I use darn here, right? Thanks. All right. So the only things you should know before getting into this too, the API is not fully baked. That's why it's a separate file in the thing I gave you. That's pretty much like they put the basics in, and now they're trying to figure out the right way to devise access. And the stuff they give actually works pretty well. I think they can do even better given the time. But so be forgiven. It's not like we're using a preview version of Visual Studio here. This is not like the retail box, right? And the dev experience. I already talked about erase versus non-erase types. The dev experience is not fantastic either, because once you load up typewriter Visual Studio right now, you've got to shut down Visual Studio and reopen it. So every time you want to recompile, you pretty much have to close Visual Studio and reopen it. Which I understand is kind of a pain. This project is not that hard.
One thing they have done that makes life a little bit easier is Visual Studio 11 has a much faster startup and shutdown time. So I'm finding, as compared to 2010, it's not as bad to have to keep relaunching it.
It's not a bug, it's a feature. Anyway, I'm sorry. But yeah, you have to reload Visual Studio, just so you know, because your compiler won't. It'll try to copy the OBJ over to the executable.
The other option is to test it outside of Visual Studio, actually using the F-sharp compiler.
I don't recommend that here. That's not what you should do here. The whole idea is I want you to see this type provider. I want you to see it. You hit dot and see the stuff you made pop up, because it feels so cool. The first time I did it, I was like, whoa! I had power with IntelliSense. It makes you feel like some sort of IntelliSense with it. So this is like the basic anatomy of what you're going to be using for a type provider. You just say namespace, empty type provider, or whatever type provider. That's sort of the namespace you open to be able to access the type provider. Then you tell it it's a type provider by putting, this is a type annotation or a attribute in .NET. You just put it on the type, and then it doesn't necessarily have to this config. The config gives you nice things like what directory you're in, which can be really handy. The compiler can tell you some things. You can just put parentheses if you don't want it. And then as this is what so like in C#, it's always this. And in F#, you can pick whatever you want. That's what you're seeing. If you're making an object here, and this is what it's going to be called from the inside. And then you're going to be inheriting the type provider for namespaces. Finally, at the very bottom of your file, you should put this assembly attribute and put do after it. So this is necessary in F# at the bottom of a file that has assembly attributes. just tell it to register those and not throw them away. So this is like the basic outline. This is also in all the samples I get that are provided. Next, this is sort of the most simple contents that could go in that, right? We have to pick a namespace name. So here it's just like an examples.td namespace. This is the namespace that this will live in. Finally, we get assembly to inject our types into. And every example I've seen just uses the executing assembly. I don't know what happens if you change this, so I recommend not. I mean, we could all die. It's possible. And finally, we have to define a type. So here, we just make a type definition. Like it's going to go in this namespace. We give it the assembly and the namespace name. Then we pick a type name for it and a base class. Now this, for you guys that don't know, this is called an option type in F#. It's one of the reasons you don't get null exceptions in F# is because we don't really use null. We use an option type. So this is either none. You can put none here, the word none, or some of something. And that instead of it wraps the thing instead of it being either. So once you pull the thing out, you know that it's been checked. So you don't have to keep checking over and over.
In the context of type providers, when would the type be none?
This is the base type.
Yeah, when would that be none? It doesn't, doesn't.
If you're making a type from scratch.
Oh, okay. I
I guess
that
first
makes sense.
struct or something. I don't know. Like, this stuff has been out for a couple of weeks, and I'm moving, and I'm doing an ML class. I've explored it quite a bit, but I don't know all of the detail. No one really does yet. And that's one of the most exciting things about this. It's really fun to learn right now. So this is where we add our XML docs to that type. So when you dock into it in the namespace, you'll get your XML docs. Now this is the delayed. You can also just give it a string with a non-delayed version of this. So you're just calling this T, which is this thing. You can imagine having a new. The new keyword is optional in F#. So then we just add our XML to it. That pops up later, and then we finally just add it to the namespace. And here we have a namespace, and we give it a list of types. This is called an F# sequence, or not sequence expression, list expression, or list comprehension. Sorry, list comprehension. And so this bracket means this is a list, and this is the only thing in the list. You separate them by semicolons if you want multiple things to list. So if you want to make T1 and T2, you say T1 semicolon T2. So this is like the basic. Now finally, you actually want to do fun stuff, like add properties to your types. This is exactly pretty much all you need to do this. You use your provided property, you give it a property name, a property type, and you tell it static, which I recommend doing because it makes the whole thing much easier. For this example, for what you're doing today, I recommend making it static. Just make it all static, because then you just dock through and you don't have to instantiate anything. You can do crazy things with type providers. Returning types that have other types and generate all kinds of types. They can generate types on the fly as you're doing stuff. But you don't need that for this. You just need static types. So, and then finally you can specify the getter code. Now this is the complicated advanced thing that you have to worry about here. And this is pretty much a quotation that you pass. This arg is going to be an expression, right? You don't need to worry about it, but you can modify that expression. Just don't worry about it. And you return your thing here in this less than, at, hello, at, greater than. That is something that the compiler will return into code later. Then you can add your XML docs here. This is the non-lazy version of that same function. And then we added the member T, which is that thing from the previous slide. And we add it as a member to it. Not too bad, right? You guys sound kind of quiet.
It's a lot to take in.
It is. And I mean, if you guys use reflection a lot, it's a lot easier, I admit. I mean, I'm a big reflection guy. I use it all the time because I'm lazy. And so this is pretty simple to me, like the idea that, the properties here and setter. You can also use fields here. There's a field provider provided field, and that might be easier if you want to use that instead. Because then you can just give it the values. Now this is the hardest part, and I'm just going to walk you through it real quick, and please ask if you need it, but this is how you do the static parameters for your type provider. Like that string that you pass in at the top and the angle brackets. This is like these are the parameters like that you pass in that tell your typewriter to do things. In this case, it'll be a path to the directory you want to provide the files from. So you say let param1, or whatever the parameter is, and then just give it a name and a type. And this will be enforced by the compiler later when someone actually tries to do this, tries to use your parameter. Then you have your T that you're going to define your static parameter on. And you pass it that, this is where your list of parameters goes. So if you have one of them, you go, like two of them, you go param1, param2. And then finally, a function that will get the thing. Now what you get, you have to cast. This is a funny F-sharp casting thing because of the way they do pattern matching in F-sharp. So this is the pattern matching on, it just pretty much says, if it's a string, call it a string arg, right? If it's not a string, it's going to throw an exception. So just like, in this case, you're always going to have a string. You can just copy this down. That's okay. Finally, we have our static provider, right? And we want to make a type from that. So we just we make a new. Imagine every time you see these, it says new. It's sort of the convention F-sharp is use capitals if they're an object. You're instantiating one. You give it your assembly, your namespace name, the type name, which is just passed to you. You can do in this case, and then the base object, which I recommend just making object or string. And then finally, in F-sharp, you don't use the return keyword. You just leave it. Whatever's left when you're done is what is returned. So you just put ty and you close off because this whole thing from here, after this parentheses, this whole thing is the second parameter to this, and this whole thing here is a lambda expression. That's probably the hardest thing you've ever done in F-sharp before is like seeing this one thing. They don't necessarily in F-sharp. You don't necessarily have to put parentheses around your lambdas. You can put another parentheses here and one here. It makes you feel comfortable. And it's all indentation based. And because I have slides with not a lot of room on them, my indentation is not quite as indenty as in normal F-sharp code. So, does anyone, you guys feel like you're ready to get started? Maybe a little bit? So the team that wins, like, gets first choice out of my IntelliSoft stuff. Now, IntelliSoft is a company I used to work for, and they are an image processing company. They actually are not real sponsors, but I really like them, and they actually have a ton of F-sharp in their code base. So, because it's fast, it's inline stuff, and they do lots of image analysis, so get to it.
So, what do we
What is the context?
A type provider that you give as a static parameter directory. I recommend opening system.io. Here's a hint. And then you use path.kit files, iterate over them inside of this, potentially. There's other ways to do it. And then return them, and there you go.
type provider that basically wants to.
Yeah, just one directory. Not necessarily recursive. You can do recursive if you want. Let's say shoot. If you really want to be smart, if you think you're a real hotshot, I recommend doing it lazily, recursively over your file system. Which if you can do, I haven't done that yet, and I will buy you dinner tonight. But not everyone in the group, just the person who did it. I can't afford that.
So, I think since we're doing left side of the room, right side of the room, right?
Yeah, I think that's fair.
All right.
Although I don't think I have enough stuff for everybody.
You don't need to give me anything. It's cool.
Oh, fine. Hope you learned something.
I'm just here. I did. I don't know. Do you want to drive?
I'm not going to
I'll pop this off.
Okay.
Okay, well.
Do you guys want to form a separate group back here, or work with people up here, move up? I don't want you to be bored. There's lots of laptops around. They all have it. Did it work?
Ahead of time, it would be infeasible.
I'd like to know if it works for you guys. I mean, you're so close. If you look at mine, it's like mirror your code.
As you start doing the ontology.
So
OData.
I'm just going to start again and talk through the end of this. All right. So
Let Rick finish up.
yeah, because I want the thirsties. I'll help.
You and me both.
So we just open our stuff. You can copy and paste that from any other ones. Start text provider. This is the boilerplate that I paid before. So the way I created it was maybe not optimal. because I created like a type and then I attached stuff to that type with static parameters. You still have to dot in, so it gives you an extra like layer, which isn't necessarily great, but it was fast to write this way. So I created the base thing, right? This is like the base dealing that we're dealing with. I just type this assembly, namespace name, path base. It's nothing special. Base type is and I like to make it erase. It's not necessary though. It just makes it go away after. That is a totally optional thing. I was also playing with erase types and trying to like understand what they do exactly, like and how it all works when I was writing this. We don't have time to get into that more today. So then we just define our one static parameter, base path string. Then we have our do statement here, which actually calls define static parameters on our base type up here. And this is like the ground type that, like when you dot into the namespace, it's the only type in the namespace dotted. So then we define our static parameters by calling the define static parameters with the list of static parameters and a function that will do our takes the name of the type that we're trying to generate, pretty much. And I got to move over. And this is like the little complicated thing that casts and names it all in one thing. Go into the room. I know what's been bugging me all night. My laptop is on this side and the code is on this side, but the edges of the screen are mixed up. So anyway, sorry. I'll hurry. So here, this just casts the next parameter automatically as path if it's a string, otherwise there's an exception. That's why it's blue and underlined, so you can throw exceptions. That doesn't like exceptions most of the time. Then I just create another base type. This is the hack that I did. It takes this assembly namespace, type name, and some of thing. And this is what I'm going to add on my properties too. From the static parameter. There's other ways to do it. So then just for the file and directory.get files, I did the conversion to underscore, but it's not really necessary. Then you go provided property for each one of those files. You're making a file property. It's got the name, type string, the is static equals true, which I guess is not that intuitive, but you want to make sure that when you're dotting, if it's not static, what you're doing is you're pretty much just making a space of types, and you have to somehow new them up. So with if static is true, you can just kind of create a tree. As long as you make sure all your properties are static, your type tree will just be dottable all the way through. So that is totally key. And here's the getter code, which has a quotation in it that just closes over the file variable and stores it for later, passes it out.
Rick, one thing I just want to point out that may not be obvious. The value coming out of that getter code is a function, and the return type of that function
Is expert.
should match the value inside of it.
Yeah, you
It
also
ultimately needs to match what you specified with the property type.
Yeah, it's
Oh,
not
yeah.
easy, yeah.
That's true. It'll throw
Because you can, it's kind of easy when you start to play with these miss that, Like if you return something that's not a
I
string.
guess so, but I mean, you're saying the property is this type here, and then this is your getter code. I think it's kind of obvious, but it was to me, but maybe, I don't know.
Yeah.
Anyway, then we go through and we just add those for each one into the type itself. We're just appending them on, sticking them on there, like I did in that picture over there. Finally, we take the type that we created and just pass it back. And so because it was called on the parent type up here, this path ty.define static parameters, it'll actually just add this type to path ty. Finally, we add that all to the namespace, just that one thing. The reason we put it in this is because it takes a list of stuff in case you have a lot of things you want to shove in there. And put our do at the bottom. But it's pretty simple overall. It's not a lot of code for what it does. And to see it in action, so just go like that, and got my thing. I can put it in desktop stuff and go like that, desktop and those double quotes. In F-sharp, you can actually name things, anything, as long as you put them into double things, which is awesome for unit tests, because when I write unit tests, I give them wicked long names that are like sentences, and then it's in double ticks, and when something fails, it says exactly what happened. It's like English in your unit test output, right? I find it easier to read. But anyway, that's the easy thing right there. Just like, directory provider.path base, we have our static parameter here, then you just dot in. Now, obviously, like this is a very simple type provider. You can do crazy things like, you know, with the lazy stuff, you can just generate stuff based on things you know in the future. That's probably what you want to do. There is one file system. There's a couple type of file system typewriters on the internet. One of them is pretty clever. The other one is really dumb. It's not dumb as an experiment. It's dumb as a thing that you would actually use because what it does is you point it somewhere and then it recurses all the directories underneath. And if you use it in Linux, it could never end eventually. And I guess in Windows too, because Windows Explorer doesn't let you make the file system into a graph, but you can use it in the command line. So it's dangerous. You got to keep those things in mind. Know that you have the type providers. Compiler might never end. All right. So finally, I just want to say that if you want to explore this stuff more, there's a ton of awesome stuff in the F# 3 sample pack right here. This is sort of what I learned from basically so far, and I'm going to continue to learn from. Like I said, this stuff is brand new. I've gotten a couple sneak peeks at it throughout the year, but you know, not enough. That it's like to really build a theory in your mind of how this stuff works, and you just play and play. I like the site because there's a lot of really good bloggers out there for F#, but it's hard to find them, and they aggregate all of those bloggers in one place. And they have the Twitters and other stuff. Kind of a nice homepage if you love F#. If you want help with F#, ask these guys on freenode.net, #F#. There's some really smart people that hang out there, like Luke Stephen Portman, who does the, what's it called?
Fake?
He did Fake, but he also did the JavaScript interpreter, yeah.
Was that IronJS?
Yeah, IronJS, yeah. Man, my brain is just not working well.
That's why you need beer.
That'll help, that'll help. And then finally, there's lots of, both on our site, if you look at any of our past talks, and we have links to Vimeo for a lot of our past talks. And then this actually is an online-only site user group that has pretty much monthly talks from a lot of the thought leaders in the F# community. It's a really cool site, and I recommend checking it out if you like F#, because you can watch, they're all 1 hour talks, so you can kind of snack them. This is just a quick thing if any of you guys just wandered into the group and want to know how to get to our thing. It's actually on Meetup. If you just search for F# NYC on Meetup, you'll find us. But this is like a little URL. It's just F# NYC. is.gd. I like Twitter a lot. If you don't tweet much and you don't want your feed filled up, then you probably shouldn't follow me. But if you like to talk about physics, types, F#, video games, follow me. And my blog will actually have this stuff on it later. Maybe not tomorrow, maybe not the next day, at least the day after that. It could be tomorrow. Just there's a lot of stuff going on for me right now. I need to get this stuff together. And I want to make sure I put some text around it so that people can appreciate what you guys did tonight. Because I definitely a round of applause for everybody because you all rock. Very good stuff. I appreciate you all coming very much. Now, you guys finished first. They actually got really far. I would like to give these 3 guys in the back here, none of them uses F#. And they got there. They got there.
Nice.
So I think that's really cool. So I'm just gonna I don't know. If you guys want to go first, I think because you were here, you sort of led it, and since you know F#, it's cheating a little bit.
Yeah, what I'd like to know is how does the underlying engine construct all the IntelliSense and the docking into the object?
Well, the IntelliSense is actually made by the compiler. The IntelliSense you get is literally the compiler with a chunk chopped off and another chunk stuck on.
Is it at runtime? Is this actual code being generated or emitting or reflecting? Which is it? Or is it actually building these classes on the fly? Because you're putting for example, there's a text, but that text then becomes an object. Like what we just saw with our naming, it was in quotations, directory, we changed it, it became the object. Is it something like dynamics? What is it?
It's the compiler executing your code and then making types on the fly.
From looking at the text?
Looking at the text.
So it's not something like what dynamic does?
No, it's nothing like that. It literally is the compiler executing code in the type provider and generating types. Now those types there's 2 kinds of types really. I talked this a little bit earlier. But
But there's a gain you because it seems to be an excessive amount of work versus just
it gains you the ability to have a new database, put in the string, and then hit dot and see all the tables in there, or if they're already joined up for you with the foreign keys, like all of the things that you can query in literally seconds, as opposed to having to like generate tables and then having to update those things if like it gets old. Like there's so many cases. Like you could, like, let's say you just wanted to play around with Netflix. You're like, I like movies. I just want to do some queries in Netflix. You just load up the OData service with Netflix, do some queries, and you can just run and play with that data all you want. It's so like.
Or parser generator. You could point it to like to something in VNF format, and peg parser. It would automatically generate the peg code, but then you would just get the API.
A very practical example too is like if you have a CSV file and the header has actual .NET types in it that you want to convert to, there's already the mini CSV generator, I think, in this one, or there's a CSV generator out there.
It's the mini CSV generator, this one will work.
Yeah. So it'll actually give you back strongly typed CSV data, like from a CSV. So especially if you're like do a lot of data work, it's huge because now instead of it being like a couple hour or even half day chore to like start figuring out even how to get your data in the system, it's like literally minutes, and then you have your data.
And I think the other thing to consider is it's a compiler extension mechanism, which means you're going to get mileage out of it, when you're doing it when you're using it to apply a general solution. For example, a type provider for OData is very useful and makes a lot of sense. A type provider that connects to one particular site and one site only that happens to be querying OData, it's too much work for that sort of case. So it's not for the small one-off case. There's legitimate
What do you mean?
levels of there's a level of economy that makes the type provider useful, and that's sort of the space where they fit.
Yeah, because just now the code was more lines than you could have written in C#.
The thing is that code isn't normally written by you. What we did here tonight wasn't really a demonstration of a user using a type provider. It was someone making a new type provider. Microsoft is like, I don't know if you missed the beginning of my talk, Microsoft is shipping like 8 type providers with it, including SQL, Entity Framework, like OData, all this stuff, and they just come and literally, with OData, you point it at a URL, and now you have types. You have strong type data from that, right?
Actually, one of the coolest ones that they're shipping is a resource type provider, so that when you need to work with a resource file, say WPF, you give it the path to the resource file, and boom, you get all your resources, typed. And just even if they weren't strongly typed, even if they were all just strings still, just the fact that you get them in a nice, neat, easily accessed hierarchical fashion is orders of magnitude easier over how you currently have to get elements out of the resources currently.
I just want to say also, there's one particular feature of this that I think is huge.
Hearing the explanation, it's not synonymous to like how somebody would extend like an expression tree for like Twitter and link provider, something of that sort.
Or like SQL metal.
Like link to SQL, link to XML. It sounds something synonymous.
It actually takes up more of the role of like a code generator, like the
but
SQL metal builder, where you give it like a path, and then it generates all of this code that you have to check in to your source control. Only you don't have to check all that code into source control.
Check one line of F#.
What's that? Yeah, one line of F#.
But it's even better because I think that there's this problem too. It's like you have this SQL metal that's generated. Now you're writing code against it. But meanwhile, there's DBA in the other room changing that database maybe.
Right. And
if he does that, since you have this generated code, you're not going to be able to know. You're not going to know the next time you try to run your tests against that particular database. And even worse, if you have a separate test database that isn't changing, it's just a nightmare scenario. And like so, what the type providers give you in a certain way is immediate feedback. Like if you build right, and then he goes and changes things, so your types don't come out correctly anymore, your code will break on your next build. And you can walk over to him and smack him.
But to me, it just sounds like a dynamic version of somebody writing link to SQL or anything of that.
But it's not dynamic at all.
Dynamic.
It's not. It is static, but dynamic in a sense of you programming on the fly.
Yeah.
Let me ask if you have.
Yeah, there's an explorative aspect.
Yeah.
One type that you derive from it. However, multiple people can derive from it with multiple objects. Can this be a way to have all of them be done at once? This type?
I don't really understand. I'm sorry. I don't
We have base type and
base type.
D1, D2, D3, D4, all derived from it.
Sometimes, yes.
Sometimes. Well, what we've done tonight, could that be a way to have one version of the device type that will fit all of them?
I don't think so. I mean, what you could do is you could make a type provider that did reflection to build some sort of proxy or something.
Okay.
There's lots of things a type provider can do. That particular case, like if you
You
want
can
lots of
have a
people to extend
factory
type, I
type
think it's
provider.
traditional IOO. And
In a way, type providers are a factory.
No, the problem was that we never knew what we were given as the device type. And we had to do reflection. We were looking at ways not to use reflection.
Once you have something like that, it becomes very difficult. It's like, I don't know, that's the expression problem. It's the expression problem. So like, F# sort of can solve it a little bit by using discriminated unions, but it solves it by sort of making you define all of your types in one place. And then, like, F# discriminated unions are literally a base type and then a bunch of subtypes of that.
Okay.
And they can be recursive. Like, this can be a subtype that actually references this type. You can do lots of that. But the expression problem is hard without higher kinds. And one thing that the team is looking at now is higher kinds, like Haskell has. It's like generics, but even more hardcore. Like,
Generic.
yeah, they're generics, kind of. There are a lot of
Meta programming is meta.
But I'm not an expert on that. I played with them a little bit in Haskell and in Scala, but I'm not an authority on higher kinds. I just read a little bit and played with
What
them.
are higher?
They're like generics, but more generic. They're like, you can say like, it's like one way of doing it is having like let's say you have T, like something of T. But what if T knew what thing is actually using it? It could make all kinds of decisions based on that. It's just like, or what if you could?
Look at us, Hawk.
Yeah.
I don't think this is going a little far yet.
Yeah.
I appreciate your question.
We're getting into the limbo here.